And so again, on Friday we did 11 cars. That's all you needed to take a picture of and turn in. However, today we're going to take a couple more cars. We're going to finish them up, and then go from there. Um, yeah, it did ask for front and back. So yeah, so take a picture, turn them over, take a picture. So yeah, just show me your flashcards. Uh, Today we have a couple more that we want to do really quick, and I'm going to do this very quickly. You have the notes. It is on your weekly schedule from last week called Intro to Parts of Periodic Table. There are three more cards that I want us to make because these are also going to be on your quiz Friday, and you can use your note cards on Friday. So if you're in person, bring them with you. You can use these, okay? All right, so real quick, another card that we want to make, and again, if you're missing a card or you lost them, just draw a really simple box. Draw a really simple looking periodic table thing, okay? So the last three cards we want to make is your states of matter, gases, solids, and liquids, okay? So for the gases, um, they are your noble gas column, which is your very last column over here on the right. There are a couple in the top right, or top right of your periodic table. You know, nitrogen, oxygen, fluorine, and chlorine. Okay, there's a couple of gases, and then hydrogen way over here all by itself. Those are all the gases that we have. They're not very many. Okay, on there, most of them are your noble gases because they're stable, they're calm, they're non-reactive, they don't really do anything, so they are gas in nature. The other ones that are not noble gases, such as hydrogen, nitrogen, oxygen, fluorine, and chlorine, those tend to bond together and they make what we call a diatomic. So O2, that's oxygen that you breathe in, O2. Not just breathing in oxygen, you're breathing in a diatomic atom, okay? Fluorine gas is F2, chlorine gas is Cl2, nitrogen gas is N2, hydrogen gas is H2. Those are diatomic elements or atoms, diatomic atoms. Okay. Those are the gases, not very many. Liquids, there's only two at room temperature. Um, and at room temperature, this is also a standard air pressure, standard room temperature. And those are all important because the pressure will affect whether or not it's going to be a liquid or solid or a gas. So there's only two on there, and those are the green ones, bromine and mercury. Okay. Now, gallium number 31 is normally a solid at room temperature, but gallium will turn into a liquid right in my hands. Like I even have some, I could probably go get some. But gallium is a solid at room temperature, but it does turn into a liquid with very, very little warmth. Okay, even just the warmth of your hand turn it into a liquid. But we do say it's a solid at room temperature. So there's only two liquids. There's no real pattern on that, mercury and bromine. For those, if there was a tiny bit of a pattern, it would be the size of the atom and the valence electrons that are kind of causing it. And then the last card that we want to make is your solids. And again, notice your solids are the gray one. It's going to take up a lot of space. Most of them over onto the left-hand side are solids, except for hydrogen way up there, which is a gas. And again, all your metals except for mercury. Okay, mercury is a liquid. But all your metals pretty much are solids on there. And so the majority of the elements on the periodic table are indeed solids. Again, a lot of those, even though they are solid, they don't stick around for very long. They're radioactive, they decay, they break down very, very quickly. Okay. All right, so you should have, how many is that? 14 cards? Yeah, you should have 14 cards now. The 11 that we did in class are then your solid, liquid, gas periodic table cards. Okay. You do not need to take a picture of the one we did just now, but I would like for you to have them so that on the quiz you can learn about more stuff. Now there are a couple more slides here that talk about the electron shape, the electron orbitals, but I'm not going to put this on a quiz, okay? But there is more pattern on the periodic table that has to do with the shape of the electron clouds. So the electrons are flying around the outer part of the atom, okay? But they're in different shapes, different patterns. So this is an S, like just a simple sphere. This is like what we call a dumbbell for P. So there are different types of shape where the electron can be located. And so there are patterns on the periodic table. So look, big block there, big block there, big block there, two blocks there. There are patterns on where the electron can be in the atom located based on where they're located on there. Okay. So we are going to have a quiz on Friday, and all this material fair game, but you have it all on these pieces of paper. Okay, so it really shouldn't be that big of a deal, but they are flashcards. I encourage you to kind of quiz yourself. Say, hey, oh, those are noble gases. Oh, those are, the actinide series. Oh, those are the alkali earth metals. Whatever it is. Okay, I do encourage you to kind of quiz yourself on those. All right. Today we will. We're actually going to do the actual activity plan for today. So if you look on your weekly schedule, you will see we do have some notes on periodic trend slide, which are on this activity right here. So if you open up this activity, actually no, the notes are up here, sorry. The notes are up here, and they are the notes for the entire week. Okay, so we're going to do some today, and we're going to do some on Wednesday, and then quiz on Friday. Okay. Now, Owen realized that there's an activity here called ATC Strategies 1. That assignment is messing up your grades a little bit, and that's because I put the wrong due date in there, but it will fix itself tomorrow. So don't worry about it. It's not part of your quarter 2 grade or anything, but it will fix itself tomorrow. Canvas only updates at midnight, and it'll fix it. Speaking of Canvas grades, quarter 2, I have to post the grades on, I have to post the grades on Thursday. So I need anything you're going to turn in, I need it by Wednesday at the last moment, okay? And even then, by Wednesday, if I get 1,000 things to grade and you turned it in at the last second, I might not be able to grade it, okay? Because they would do 2 weeks ago when end of term ended last Monday, okay? So if you're going to turn in anything, it's got to be as soon as possible if you want to fix your quarter 2 grade. And you can turn in anything that's low or missing or whatever else, okay? And again, by Wednesday, you got to have it, okay? And I hope you did some stuff over the weekend for that. All right, so today on a weekly schedule, we are going to do the parts of the periodic table. So I'm going to click on these notes up here, click on that, and then you get a periodic trend PowerPoint. So you have this PowerPoint here. Again, you have it. If you want to make notes, or if you want to make your own copy, you make your own copy. I would highly encourage you to have a paper and pencil next to you to make additional notes as we talk about these things. But today we're going to talk about the trends that are on that periodic table. Okay, so the periodic table is arranged in certain ways. There is a pattern for solids and liquids and gases. There is a pattern based on reactivity and what happened to the electrons. There are a lot of different patterns on there. And so today we're going to talk about some of those trends. So hopefully you guys have this. Go ahead and click on it. Follow along with me. I'm going to present it. And we're just going to do the first couple of slides today. We're only going to do 1 through 7 today. So it's pretty quick. All right, so the first term we're going to talk about today is the size of the radius of the atom. Okay, the size of the radius of the atom. The radius is just like in geometry math class. The radius is from the center to the outside. So same thing for the atom. It is from the nucleus, the center, to the outermost electrons, the valence electron. Okay, that is the radius or the size of the atom. So if you look at this picture over here on the periodic table, which is, it doesn't have any boxes, but this is the periodic table, you can see the pattern. Okay, look at row number 2, lithium. And then look at the next one, and look at the next one, look at the next one, look at the next one. They actually get smaller as you go across the periodic table. Okay, now here is the part that a lot of kids get confused. Is that as you go across the periodic table, you're adding protons, you're adding neutrons, you're adding electrons. So why are they getting smaller? Okay. I'm on the notes. Oh, sorry. Am I not sharing? Sorry. I don't know what happened there. All right, so again, these are the notes. Follow along with me. That are the notes on your weekly school. So anyway, so trait number 1 is atomic size radius. So radius is collecting geometry class from nucleus to the outermost electron. All right. So if you look on the periodic table, if you look at the second row, you see that the atom is getting smaller as you go across the table. Now, a lot of kids have a problem with this because as you go across the table, you're adding protons, you're adding neutrons, you're adding electrons. Why is the atom getting smaller? Well, you got to remember the protons and neutrons are stuck in the middle. They don't do anything with the size. Right? The second row only had 2 rings for the electron. Remember, we draw them 2 rings. So you're not adding more rings. It's not getting bigger. Okay, I don't care how many electrons you put on there. It's not going to get bigger for the second row. But what's happening is you're adding more protons, and those protons are going to attract that ring of electrons. So more protons, you're going to get more attraction, more attraction, more attraction, more attraction, more attraction. It's going to make that second ring of electrons smaller and smaller and smaller and smaller if you add more protons. But then you're going to add a third ring for sodium. Look on there for sodium. Sodium gets big again. Okay? And then you add another proton, another proton, another proton, another proton, another proton, and the atom gets smaller as you go across the periodic table. Okay? Because you're adding protons. So again, the rings are what make the atom big. So hydrogen had 1 ring, lithium had 2 rings, sodium had 3, potassium 4, rubidium 5, cesium 6. Okay, those are what are making the atom bigger. But then, when you add more proton, neutron, electron, those protons are going to make the ring get smaller and smaller and smaller and smaller and smaller because they're attracted to that ring. And I hope that makes sense. Okay, so the atom is mostly empty space where the electrons can move. As you move across the table, the outermost energy level is filling up. Does not change. It's still ring number 2. It's still ring number 2. It's still ring number 2. Okay, but you're adding more protons, and the attractive force between the proton and the cloud starts shrinking. Okay, and that's pretty much what I said there. All right. So as you move down the periodic table, you're adding more rings. Okay, so the electrons are getting bigger and bigger and bigger and bigger. Okay, and so therefore, as you go across the periodic table to the right, the sizes are going to get smaller. If you go down the periodic table, the sizes are going to get bigger. Those are the rings: 1, 2, 3, 4, 5, 6, 7. Okay, and then again, you can look at these Bohr models here. Okay, they all have 2 rings in this row. All have 2 rings. So the atom's not getting bigger. Okay, as you go across, it's not getting larger, but you are adding more protons, and so therefore the protons are going to be pulling on those rings. Now, when you get down here, you're adding a third ring, so it's bigger. Okay, but as you go across, it's still 3 rings, 3 rings, 3 rings, 3 rings, 3 rings, 3 rings, 3 rings. It's still 3 rings. So the atom's not going to get bigger as you go across the periodic table. Okay, but it is going to get bigger as you go down the periodic table. Okay, 2 rings, 3 rings, 4 rings, 5 rings, 6 rings. Okay. Again, hopefully that makes sense. All right, so in general, for your periodic table, the smallest is hydrogen or helium, and that is true. Smallest is helium, and it's going to go down and to the right, whatever direction that is. It's going to go down and to the right, and francium in the seventh row, number 1, 87 francium. That is going to be the largest atom there is because it has the most rings and the least number of protons in that row. That's pulling on it. Okay. So the size of the atom is really important. Now, the size of the atom is also going to affect its reactivity. Okay, is it too big? Is it too small? Is it in the middle? Okay, and you notice that the transitional metals are kind of in the middle with size. So things like gold and lead and iron and nickel, they're not super reactive. And part of the reason is it has to do with the size of the atom and what's going on there. Okay. I think that's it for something. Yeah, that's it for today's kind of notes on there. I want to give you guys plenty of time to do that. Okay. All right. So the atomic size or atomic radius. Okay, it's from the nucleus to the outermost electrons. Okay, and again, please remember, especially for the Bohr models, that those rings are not. They don't exist. They're just an area. Okay, just like the Earth's orbit around the sun. It's not a hula hoop, and the sun is sitting on an Earth is sitting on a wire going around the sun. That's not how that works. Okay, but the same thing for electrons. Electrons, they don't have to stay on that ring. Okay, but they're just somewhere in that area where that ring is, and that ring is also three-dimensional too. So that's the other part that you got to remember. The downside to the Bohr model is that it's not super accurate for drawing purposes, but it gets the point across on there. So, all right, today I'm gonna put you guys in breakout groups. We are gonna do activity, whatever it was called. It's a gizmo for atomic size, atomic radius. So when you click on your worksheet, you're gonna get this worksheet here. You need to make your own copy like normal. But then we're gonna play around with the gizmo a little bit. I put it on there, so it should be good. And then you're gonna collect some information about that gizmo. So again, if you click on the link, it will pop up this gizmo here. I'm not logged in. You need to log in so that it doesn't do the timer on you. Okay, if you, oh, sorry, I'm not sharing my screen again, am I? You need to get logged in to the gizmo so that it doesn't do a timer on you. So again, on that worksheet, there's a link. Just click on the link to get to the gizmo. I already shared it with your class, so you guys should be able to open it pretty quickly, pretty easily. And then you're going to look at the atomic radius, atomic size. There's a ruler here. If you want to measure some stuff, you can actually measure something. So, pull it to the nucleus, to the outermost electron. And then this over here is the atomic radius, this number. You can actually save it, and it will type it down here for you. Okay, you could do the next element, next element, next element. Okay, again, notice from the nucleus, you can pull on it, go over here. Notice what happened to, I don't know if you guys saw that a second ago, but notice that this is not the same size anymore, this ring. Well, that's because helium wasn't the same size. Helium made it smaller. And helium made it smaller because now there are two protons that are pulling on those electrons, and it just makes that ring a little bit smaller. All right, so the next atom, again, we're going to do the same thing. We're going to just measure from the nucleus to the outermost. This is the number. You can save it right there. Okay. Again, you can actually make cars, whatever you want to make here for these cars. Okay, look, that one's way too big. Pull that one over there. You can save it over there for carbon. This is what you're going to be doing today with your classmates. So help each other out. There are a couple of questions that you want to answer, but I do want to give you as much time to work on that so that you guys can have plenty of time. If you do not finish the activity today, please consider it homework. Please consider, maybe trying to get it done tomorrow during Tuesday, Thursday lesson. Tomorrow we have an ACT strategy that I would like for everybody to do, even those kids that are in dual credit. Okay, I think it's a 10-minute video and take some notes. So I'm going to ask everybody, even dual credit kids, to do that activity. And the reason why I'm asking dual credit kids to do that also is because it's impacting your grade not to have any professional habits in there. So you got to have at least some professional habits. And so that's going to be the first one that we do for this quarter, is some ACT strategies. Plus, it will benefit everybody to do that activity. That's kind of an important one for us. All right, so I'm going to let you guys go into breakout groups. I'm going to stop the recording because it's not really going to help anyways for during breakouts.